Hello everyone, welcome back to my lecture sessions. In today's session, we'll discuss one more topic from AI, that is unification and lifting. We will also see algorithm for unification and also we see an example. First, let us know what is meant by lifting. For unification to perform, first of all, we have to perform lifting. Lifting is nothing but selecting inference rules or sentences that we are going to use for in our unification algorithm. Okay, so what is meant by unification is we will be selecting two sentences. Okay, so those two sentences with the actually they look different, but our aim is to find some substitution that will make both sentences look alike. So that we call as unification. Okay, so it is nothing but it is a process of finding substitutions for lifted inference rules that make a different logical expressions look identical. Actually, there are two different logical expressions, but with the help of this substitution, we are making them to look identical. So this we are calling as unification. So if you see the syntactical form of this, okay, unify of P comma Q. So here P and Q are two sentences equal to theta. That is the substitution where substitute of theta comma P is equals to substitute of theta comma Q. So what does this mean? We are lifting these two sentences that are P and Q and we are finding a substitution that is theta with the help of which we are making two different logical expressions to look alike. So that's what the meaning of substitute of theta comma P equal to substitute of theta comma Q. Let's see an example. Okay, here we have a query to solve, that is whom does John know? Okay, so let's formulate this in the form of an inference rule. Okay, John knows X. Okay, so here this X is the one that we should find out. Whom does John know? Okay, so this asks where's. So now answers to this query can be found by finding all sentences in the knowledge base that unify with John comma X. Okay, so now let us go back to the knowledge base and find out what are the relevant sentences that can help us to solve this. Okay, so this we will do with the help of unification algorithm. So first let us discuss what is unification algorithm and let's see an example. Okay, so the aim of unification algorithm is to find most general unifier. Okay, we are trying to generalize. MGU in short, it is most general unifier. So the algorithm looks like this. Unify of x comma y comma theta returns a substitution to make x comma y look identical. Okay, so this is what we have seen in the definition. So here x or y can be a variable or it can be a constant or it can be a list of elements like an array of elements or it can be a compound expression involving sub-expression. Okay, so that we call as a compound expression and theta is the substitution. So now if theta equals to failure, then failure will be returned. When it will be a failure, there is no substitution found. Okay, so in that case, it will be a failure. Otherwise, if x is equals to y, so now both x and y are looking alike. In that case, what you should do, you should return theta. Otherwise, if you have a variable in the form of x, okay, so then this algorithm will be returned in the form of unified var of x comma y comma theta. Okay, so here we have the algorithm for unify var. Okay, so let me show you the form of this with the help of the example. So here, so these are the statements that we have searched in the knowledge base. The first one, if you see, knows of John comma X. Okay, so this is one sentence and knows of John comma Jane. Two sentences we have found out. Okay, so the first one is P, second one is Q. Okay. This is our P and this is our Q. So now from here what you can see, so if you observe, in both the sentences I have John and John, and then in place of X as a second argument I have Jane. So what I can do, I can take X substitution Jane in place of X. Okay, so this is the form of the first step. So that means if you have a variable X, so in that case we will be calling the algorithm unify var of X comma Y comma theta. So let us see this unify var of, okay, var variable comma X comma theta. What does this return? It returns a substitution theta. So now if var is substituted with a value, okay, so then what does this algorithm will return? It will return a value comma X comma theta. So that is what we have found out, right? In place of X we have substituted Jane. Next, suppose if you have a variable Y, okay, so now we will invoke unify var of Y comma X comma theta. So now in place of this var, okay, so we are invoking Y comma X comma theta. So let's see the form of this. So here you can see John unify of nose of John comma X, nose of Y comma Bill. Okay, 1 minute. Let me clear the screen. Yeah. So now if you observe, so this is my sentence P and this is my sentence Q. Okay. So now we are taking substitute. Already I have found out substitution for X. The same thing I can use here, or from this sentence what I can understand. So here you can see in place of John I have Y, in place of X I have Bill. So these two I can make equivalent. So now if I take a substitution for these two, so now both of them will look alike, right? Isn't it? So now we are replacing X with Bill and Y with John. Okay. So we are done with the second one also. Suppose if you have a compound sentence, okay, so that means an expression involving one more, that is what we call as a compound expression, right? Here a predicate involving one more predicate is called as a compound expression. Similarly, a list of elements. So if you take a compound expression, what we will do is, first we will call the unify algorithm with x dot op comma y dot operation, x dot operation comma y dot operation. So while performing this operation, what we do is we take the first argument of x and first argument of y, and then we call the, once again we call unify algorithm. So that means complex one we are trying to make it a simple one. So that might match with any one of these two forms. Okay. For example, if I have P of Q of X, so then what I will do, and one more I have like R of S of T. Okay, so then first I have to make this compound into a simple one. So that means first I will pass Q of X comma S of T to this unify algorithm. Okay, so after finding the result of this, whatever I will be obtaining, so that will become the expression for P and for R. Result and result one. So like this, a compound expression I have to make a simple one. So here it is a compound one. Now I made it a simple one in two steps. Suppose if this expression is involving furthermore compound statements, in that case, in all the cases you have to take the first one from P and first one from R. Similarly, second one from P and second one from S of T. So like that, you have to take the arguments respectively. Okay. So the next case is, suppose if you have a list of arguments. So then what I should do? Okay. So if I have a list of arguments, first I have to take x dot first comma y dot first, and then I should apply the unify algorithm. After that, I should proceed for the rest of the elements of x comma y. Okay, at every step after performing this, once again our unify algorithm will fall into one of these two cases, either 1, 2, or it might be of case 3 also, but this also will in turn result into the form of 1 or 2. So in that case what will happen? So here you can see a compound statement. So in the knowledge base we have nose of John comma X, nose of Y comma mother of Y. So here in place of this we have a compound statement. So now in this case what we will do? First we will try to take substitution for Y. Okay, so for Y the substitution is John. For X what is the substitution? It is mother of Y. And already first substitution is mother of Y. Okay, so the compound statement, I should make it simple. Okay, so with this I will be calling the unify algorithm. And once again now for Y I have a substitution. Okay, so that will be substituted, that is mother of John. So this is how we make a compound statement to a simple one. Next, suppose if you have any statement in the knowledge base like this. For example, I found a nose of John comma X and nose comma X comma Elizabeth in the knowledge base. So in this case, can I take a substitution? Let's see. Here for X I have John. So I can replace X with John. Okay. Next, for the same X I have Elizabeth also. X should be substituted with Elizabeth. So now one variable cannot have two parallel values in the same one. So what I should do? So this is called as, so this is a problem. So it will return as a failure. So in order to overcome this failure, what are we supposed to do is, so we have to apply standardization. What is meant by standardizing is, instead of taking the same substitution variable for both the values, you can rename any one of the variable with a different name. So for example, here you can see nose of X comma Elizabeth. So in this expression or in this sentence, I can replace this X with X17 to make it a new variable name, and another one I can keep it as X itself. So now if you see, the X, the sentences will become like this: nose of John comma X comma nose of X17 comma Elizabeth. So now these two are two different variables. So now I can take substitution for X as Elizabeth and substitution for X17 as John. Okay, so now if we, so this is the unification algorithm. Okay, and here if you see the last step, occur check. So here we are just checking whether variable comma X is it there or not. If it is not there, then it will return as a failure. Otherwise, we will try to add variable of X. We will take a substitution for this variable, that is X, and we will try to add it to the theta. So here, so all these are our thetas after equal to whatever we have. So all these are our theta, that is the substitutions which are making these two sentences look alike. So now let us generalize. So let us see the subsumption lattice also. For example, if I have one more query like employees IBM comma Richard. So from this, what are the different questions that we can frame? So earlier we have seen we had a query. So for that, from the knowledge base, we try to identify what are the facts available in the knowledge base. So now I have a question. So from this, I am trying to make some more questions so that I will add more and more statements to the knowledge base such that it will give me answer for any type of query that is related to this. Okay, so these are the four queries that we have formed. So that is, does IBM employ Richard? So this can be written as, this is the one that is given, IBM comma Richard. So now at a time for one constant, I can take the substitution. So that is, first time I'm taking substitution for IBM. I'm replacing it with the variable X. Okay, so with this, what I can frame. So I can frame a question like, who employs Richard? Next, I am taking substitution for the second constant, that is Richard. So my sentence becomes employees of IBM comma Y. So how can I read this? I can read it as, whom does IBM employ? So in the next step, already I have substituted for Richard. So now I will also substitute for IBM. So it becomes employees of X comma Y. So this becomes who employs whom. Okay. So for this, let us try to form a subsumption lattice. And so in the first case, we are taking two different employees of IBM comma Richard. So here if you see, the constants are different. So it is in the form of X comma Y. So in the second subsumption lattice, we will be having in the form of X comma X, that is John comma John. So here employer is the same and employee also is the same. So whenever you have some sentences like this, how does the solution look like? How does the solution graph looks like is, so here let us see the first case, employees of X comma Y. So related to this, what I have in place of X, I have this statement in the knowledge base, employees of X comma Richard. Okay. Next, if I take substitution for X, then I have one more statement like employees of IBM comma Y. So now for this question I have taken who employs whom. So for this we are trying to find out the solution. So that solution you can find like this. First of all, whatever sentences or facts are available in the knowledge base, that we should identify. So these two are available now because these we have added in the knowledge base. And from these two, what I can derive? So here X can be substituted with IBM and Y can be substituted with Richard. So the final answer I got is IBM comma Richard. Who employs whom? IBM employs Richard. So that is the answer we got. Okay, so this is the first case. In the next case, you might have a question like this, employees of X comma Y. So this in turn may result into employees of X comma X form when both employee and employer are the same. So for example, so here I once again from the knowledge base I am taking employees of X comma John. So now the name, only the constant I am changing. Already in the knowledge base I have employees of X comma Richard. So now this Richard is substituted with John. Okay. So next time I am taking substitution for this IBM. So this IBM also I am replacing with John, employees of John comma Y, and from these two, so if you observe these two, X is replaced with John, similarly Y is also replaced with John. So the result of both the variables is same. So I can also rewrite it as employees of X comma X. So the result of this is employees of John comma John. John employs John. Okay, hope you liked the video. If you have any queries, please let me know in the comment section. If you like the content, please do like, share and subscribe. Thank you.